So there are a few very common questions in my videos that are pretty good questions and would be interesting to answer, but that don't quite warrant an entire video on their own. So in this video, I'm going to answer some questions that you guys sent me about backups, C-states, power efficiency in the Homelab, the ARM architecture, and of course, whether Powertop implies the existence of power bottom. And once you've built a power efficient home server after watching this video, you're going to have to put it to some good use, right? So why not learn backend development with the help of today's sponsor, boot.dev. Boot.dev is a learning platform that teaches you backend development from scratch with multiple different learning paths featuring languages like Python, Go, and TypeScript. You can see by its interface alone that boot.dev is made for true gamers, with features like boss fights, quests, XP, and achievements that are basically supposed to activate your gamer brain and make sure that you never get bored while learning. All of their courses also make you apply your knowledge from the get-go and feature real projects that are close to typical tasks that you'd be doing at work. Now, learning to program is not easy, and boot.dev is not trying to sell you a get-rich-quick scheme. Their entire curriculum takes around 12 months to complete and can be fairly challenging for a beginner. However, if you ever get stuck, boot.dev features a vibrant Discord community where members can help each other out, share tips and knowledge, and just hang out. So go ahead and try boot.dev for free. All of the content is free to read and watch in the guest mode, but a paid membership unlocks all the interactive features which really make the platform shine. Check out the link in the description and use my code Wolfgang to get 25% off your first year if you choose the annual plan. So thank you boot.dev for sponsoring today's video, and now let's get to question number 1. I live in Brazil where most of the budget options for Homelab are still quite expensive. Is it worth it to go with decommissioned servers in that case? Find an office sale? So with decommissioned enterprise servers, you're usually going to have 3 issues: power draw, noise, and heat. Cheap enterprise gear, especially one that is cheap by Brazilian standards, is probably going to be old, so it's going to generate a lot of heat. If you have an AC at home, it will have to work harder to dissipate all that added heat. An enterprise server is also not going to be optimized for silence. It's probably going to have high RPM industrial fans which are made for pushing as much air as possible and not for peace and quiet in the living room. If you're okay with these 2 things, for example, if you have a non-living space where you can put the server so that the noise doesn't bother you or produce an additional load on the AC, that leaves only one problem: power draw. And whether it's worth it to buy a less expensive, older PC that draws more power will depend entirely on how expensive the power is where you live. So here's a simple Excel sheet that I whipped up using the magic of AI. We entered the hardware price and power consumption of both systems here, and then the energy cost per kilowatts and how many hours a day we're going to run the systems for here. So for Brazil, let's say that the cheaper server is 50 euros up front and will draw 150 watts on average. And the more expensive server is 400 euros, but will draw 30 watts on average. As for the usage, let's say 24 hours a day. And as for the price, let's go with 10 cents per kilowatt or 0.10. And as you can see, in this situation, it'll take us 41 months or 3.5 years before the more expensive system reimburses itself. If you're planning to keep the system for that long, I'd say it's definitely worth it to invest into a more power efficient rig. And here's how the equation changes in a country with more expensive electricity. For example, in Germany, where a typical price is somewhere around 30 cents per kilowatt, as you can see, we actually break even on the price tier system after a year and 1 month. And by year 3, we actually save 583 euros by running a more power efficient rig. Obviously, if you have solar panels, this equation would look a lot different for you. But for the rest of us, this is pretty much the way to figure it out. As for decommissioned gear and business sales, I would definitely take a look at decommissioned office PCs. These will usually have consumer or workstation grade CPUs, which has its upsides and downsides. But I think that for dipping your toes into the Homelab stuff, an old office PC might make more sense than a rack mount server PC. It would be a lot less loud and not as hot, and would probably be based on consumer or workstation grade components, which will draw less power. Sure, it probably won't come with ECC support or a hot swap drive backplane, but if you're just looking for a budget-friendly beginner option, I think that an old decommissioned office PC is a better option. I'm gonna put a link to the Excel sheet down in the video description, so feel free to play around with it, even if you're not from Brazil. I would like to see something like an introduction into configuring C-states for a home NAS. researching C-states online kind of feels like researching IPv6. Most answers that you'll find will basically amount to disable it to avoid problems, which is not helpful. Now, as a rule, making sure your system is able to go to power-efficient C-states is not hard. 1. Reboot into BIOS and make sure that all options that have ASPM or PCIe power management are explicitly set to enabled. Some systems default to auto, and auto often means disabled, weirdly enough. 2. Install Powertop and run Powertop ---- Autotune as root. And 3. Make sure that all of your devices that do support ASPM have it enabled. For that, you can use a little script that I wrote, which I'm going to put down in the video description. After all of that, provided you have an Intel CPU, run sudo powertop, switch to the idle states tab, and look at the C states in the top left corner. If you have more than 0% for C3, congratulations! Your system is pretty power efficient, but you probably have a PCIe or a SATA device that won't let it go into a more power efficient state. This is fairly easy to verify with PCIe devices using this command, which I'll leave in the description. As you can see, on this particular system, there are some devices which don't support ASPM at all, so that will usually be the culprit. If, on the other hand, your system goes into C6, C8, or C10 in Powertop, that basically equals the perfect score, and it doesn't get much better from here in terms of C states. Now, I did say earlier that this only makes sense on an Intel CPU, and that's because Powertop is a tool that was initially developed by Intel, and can only reliably show packaged C states on Intel CPUs. If you want to know which C states are supported on your Ryzen CPU, you'll need something like Ryzen Monitor, which uses the SMU data to detect the C states. I'll leave a link to this tool down in the video description. Keep in mind that older AM4 CPUs that are based on Zen and Zen Plus architectures will probably require you to disable C-state support on Linux entirely due to instability and crashes. But Zen 2 and newer will support C-states just fine. Now, if your system doesn't go into C6, even with no PCIe or storage devices connected, so just the motherboard, memory, SSD, and that's it, this is where it gets tricky. Some motherboards just have crappy BIOS implementations that hardcode the ASPM settings and don't expose them in the BIOS menu. Some will go into the lower C states just fine when a PCIe card is connected to the first PCIe slot, but won't when it's plugged into the second one, and so on and so forth. Personally, I don't think that something like C3 is the end of the world, and I definitely wouldn't buy a whole new motherboard just so that my system would go into C6 or C8. Even in the worst case scenario, we're looking at a difference of 10 to 15 watts. But feel free to use the Excel sheet that I mentioned earlier and see for yourself whether it makes sense for you economically. Correct usage of Powertop on like Proxmox, e.g. I don't want my Pi hole to suffer on any performance. So a lot of people think that enabling power saving options or using tools like Powertop will somehow hurt their performance. It won't. The only thing that enabling C states or running Powertop Autotune does is let your CPU go into those power saving states when there aren't any resource intensive tasks taking place. And it's definitely not going to hurt the performance on your Pi hole. In terms of how to use it, pretty simple, just run Powertop Autotune as root and it should be good to go. You can also optionally run my Auto ASPM utility to enable ASPM on your PCIe devices as well. And that should take care of the optimizations that you can do on the OS itself. I would be interested in more details about configuring HDD spindown configuration. Does it make sense as it saves energy, or is the possibly shortening of the HDD lifetime not worth it? I've actually already talked about hard drive spindown in this video of mine at this timestamp, so I'll just leave this here instead of saying the same thing again in this video. But we do have another spindown related question as well. In one of your videos, you spoke about HDD spindown, but how do you prevent your HDD to spin up? It looks like my OS, which is Proxmox, keeps spinning them up whatever I do. And how can you know which app or service wakes them up? Now, the first order of business will be to make sure that your OS and any of your virtual machines, LXCs, and disk images are on an SSD. Next, take a look at your systemd timers and cron jobs, and see if your system is running a smart check or something similar. If it's running, let's say, every hour, you can probably get away with just running it like nightly. Failing that, there are a few tools that you can use to see what's waking up your drives. There's FatTrace, which will show you whenever a file or folder on your system is accessed, and you can use grep to filter for a mount point of your hard drive. There's also BLK Trace, which monitors the block device directly instead of a mount point, And finally, there's Powertop, which will display some applications that are writing to the drive, but won't show which drive they're writing onto. Now our next question is an all-solid-state NAS viable in 2025 for a beginner? And I think that mostly depends on how much storage you want in your NAS, how bad you want it to be all solid-state, and why you would want it to be solid-state in the first place. SSDs are still vastly more expensive than hard drives in terms of raw price per gigabyte. So if you want to build one, it's probably for one of the 4 reasons: power draw, noise, space, or speed. Now, power draw wise, you'd have to run SSDs for a long time before it starts making sense economically, way past the mean time to failure for most SSDs. So that's probably not a good reason to throw away your hard drives. Noise-wise, depending on your situation, you can always place your NAS a bit further from your living or working space, or spin your hard drives down when they're not in use. Space-wise, as much as I enjoy an idea of an ultra-compact NAS, for most of the use cases out there, the cost just doesn't justify the space savings, especially considering how many super compact off-the-shelf pre-built NASs there are out there that actually let you run your own operating system on them, from companies like Ugreen, AOStar, and so on. And in general, most of these concerns can either be eliminated or at least made a bit more bearable by having a tiered setup. Hard drives for bulk archival storage and stuff like media, and solid-state drives for frequently accessed data like databases, application files, and so on. There are very few cases in which you'll want SSD speeds for all of your data, even for video editing. Yes, you do need fast storage during the editing process, but once the video is edited, you're probably going to be okay with a slower medium for archival and backups. Coming back to an SSD-only setup though, whether it's viable for you will depend on how much storage you need and how much more you're ready to pay for an ultra-compact and a low-noise NAS. If all you need is, say, 8 TB of raw storage, an all-SSD setup will still definitely be more expensive than a hard drive setup, but at the same time, we're talking about 300 to 500 euro difference. Still, this price gap gets considerably larger the more storage you need. So unless you're made of money, or have some sort of an OCD that requires absolute silence from your NAS, I would definitely consider a mixed solution. Homelab on ARM? As a maintainer for ARM BNOS, I'm wondering when we will see you build an energy-efficient ARM-based NAS. I've built a few in the past couple of years, and it would be great to see your take on it. Yes, we want a Rockchip RK3588 8-core home server with an idle consumption of 2.1 watts. And yes, this is something I'm also interested in doing, but if I were you, I would definitely adjust my expectations when it comes to ARM power efficiency. Now, ARM is definitely more power efficient than x86 under load. But when it comes to idle to lower load power consumption, which is where your server is likely to spend 80 to 90% of its time, pretty much all semi-modern x86 CPUs will draw as little as 1 to 2 watts. That's just the CPU itself. What contributes the most to your server's power consumption is, well, the rest of your system. Chipset, NICs, memory, PCIe devices, hard drives, SSDs, and so on. And those things, well, maybe apart from the chipset, will not get magically more efficient on ARM. And I think that x86 devices like Latte Panda Sigma demonstrate that pretty well. The entire computer draws like 3.6 watts from the wall. I mean, if that's not power efficient enough for you, I don't know what is. I've also talked about ARM in the Homelab in this video at this timestamp, so go check it out if you want to know more. But like I said, I'm definitely open to trying it out, and will hopefully do an ARM-based build this year. How to expose services through double NAT, no public IPv4. Well, there are a few ways to make your services available outside of your home network, which all boil down to 2 options. Exposing your services to the outside world wholesale, so things like Cloudflare tunnels, Pangolin, or port forwarding on your router, or making your services available to a select few clients. So that would be setting up a VPN tunnel, or using a service like Tailscale or Headscale. In my experience, Tailscale is super easy to configure, and if your service will have a limited number of users, and all of those users are able to install and use a VPN client on their devices, I would pick that over actually exposing my services to the outside world. This will greatly reduce your attack surface and make any security-related bug or a misconfiguration in your OS, application, or IDP provider a lot less catastrophic. Now sure, as someone who hosts a small Nextcloud or Jellyfin instance for friends and family, you're a lot less likely to be targeted by hackers than someone like Google, Microsoft, or Facebook. And provided you do everything correctly, run up-to-date software, and have strong security posture, you should be okay. But a lot of people in the Homelab space have this dangerous half-knowledge, to where they know just enough to punch a hole through their firewall, but not enough to realize that this will give anyone in the world access to all their files and services. However, this other question raises a different issue: how to share services with friends and family. I would like a user-friendly way that is secure, besides a VPN. I can't expect them to have a VPN active all the time, and it also doesn't work if they are in their own home network. Now, if your friends or family only need to access the service in their home network, depending on their router setup, you might be able to set up a VPN tunnel directly on the router. And you don't even have to funnel all the traffic through the VPN, since a lot of common VPN protocols support IP or domain whitelisting, aka only using the VPN connection for a select list of IPs or domains. Finally, if a VPN or a VPN-like service is definitely not an option, I can definitely recommend something like Cloudflare Tunnels or Pangolin. These services work even when you don't have a public IPv4 address and don't require you to punch holes in your firewall or do port forwarding. I've never used Pangolin, but for Cloudflare Tunnel, you basically just run a small Docker container or a native systemd service and tell it to expose the service that is on port, let's say 8080. Security-wise, you can isolate the service that you're exposing, as well as the Cloudflare Tunnel container pretty easily by putting them on a separate Docker network. Finally, as evil as Cloudflare is, using a Cloudflare tunnel does hide your IP address, so you can actually expose services directly from your home server without revealing your home IP address, which in my opinion is a killer feature. Can you elaborate on the differences between TrueNAS plus apps versus a quote-unquote DIY solution? How did you quote-unquote compensate for all the things integrated in TrueNAS, like backups, SMB server, smart monitoring, and so on? To be fair, all of these features are still present on a general-purpose Linux distro. It's just that they don't have a really nice and intuitive web UI. Now, personally, I prefer code as a way to configure my servers instead of a web UI. Unlike mouse clicks, toggles, and checkboxes, code from tools like Ansible, Terraform, or even NixOS is easily reproducible, portable, and can be tracked and versioned in a Git repository. The learning curve is a lot steeper than figuring out a web UI, but if you're a control freak like me, and if you like tinkering with your servers, learning a tool like Ansible, Salt, Puppet, or NixOS might be worth your time. Now, this concept is not new, and I was personally convinced that infrastructure as code is just better by reading this blog post by Alex Kretschmar. Except, since I use NixOS, even the part about manual configurations and discipline doesn't apply anymore. There are actually very few things in NixOS that you can configure on your system outside of using the Nix programming language and NixOS rebuild, which is a good thing. If you want to know more about the software configuration of my main media server, check out this video. I would really want to know more about the software situation of your remote backup strategy. What is your backup process? And how frequently do you test restores? So there are 4 things that I make backups of: my laptop, the configs and user data for the applications on my home server, stuff like Jellyfin, the RStack or Nextcloud, my paperless database, and the original source files for my YouTube videos. Now, my laptop is probably the easiest. I use Time Machine and back up to my home server via Samba Share, as well as another network drive at work. Time Machine does support encrypted backups as well, so you can theoretically back it up to any sort of untrusted medium as well. My paperless data, as well as the app configs for my Homelab services, are backed up weekly from my SSD array to my hard drive array, as well as to Backblaze B2. Backblaze B2 is basically an S3 compatible backup endpoint that gives you 10 GB of space for free. I use Restic for both hard drive and B2 backups, and I've been pretty happy with it so far. Then, when it comes to the raw footage from my videos, my parents' NAS has 30 TB of available space, and I basically use Tailscale on Borg to synchronize my YouTube archive folder over to my parents' house once a month. I've already made a video about that backup setup, and you can check it out here. As for restoring, I have successfully restored my Restic backups a few times, but I don't really have a system in place for regularly verifying the backups, which would probably be a good idea. For now, I'll just take a look at my Restic snapshots every now and then, and make sure that they're not like empty or anything. What's a good introductory product to get family or friends into local backups/cloud backups who have little PC experience and want media backed up? If they're a Mac, I think Time Machine is a pretty good option. It works with external drives as well as Samba and NFS shares. For cloud backups, I'd go with Backblaze Computer Backup. It works both on Mac and Windows, has unlimited storage, and they'll actually ship a hard drive to your house if you need to restore the data. It's also pretty easy to use for non-technical people, so I would definitely try to get your family on that. What cheap and reliable VPS providers would you recommend for self-hosting tunneling services like Headscale? Now, I'm actually not going to recommend one particular VPS provider because I have no idea if they're going to exist by the time you're watching this video or if they're still as good. But there are two websites which I personally use when I'm looking for a cheap VPS: Low-End Stock and Low-End Talk. The first one is basically just a list of some cheap VPS plans, and the second one is a forum where companies often post deals and discounts on their VPSs. For a Headscale node, you're going to want to have a unique IPv4 address, as well as KVM or Xen as a virtualization technology. Last time I checked, a lot of OVZ-based VPSs didn't have a WireGuard module in the kernel. To UPS or not to UPS. So I did mention in my last video that I actually don't have a UPS in my home lab, and that's not because I think UPSs are useless or unnecessary. It's just that since living in Germany, I haven't experienced a single blackout, brownout, or a power surge, so I don't see a reason for investing into one personally. Now, some people in the comments were not happy about that. And yes, if you do have unstable electricity where you live, or maybe not even unstable, but just a few brownouts here and there, I would definitely invest into a UPS. Sure, it's pretty unlikely that you'll lose all of your data because of a blackout, since most file systems these days are journals, but shit happens, you know? So if the hardware in your rack and the data stored in it is more expensive than the cost of a UPS, I'd say it's definitely worth it investing into one. How do you structure your storage pool? RAID, MergeFS, ZFS, Btrfs, or just basic volumes? So my storage setup is a little unconventional. When it comes to hardware, I have 4 2TB SSDs, 4 16TB hard drives, yes, I recently bought a fourth one because I was running out of space, and 1 NVMe boot drive. The 4 SSDs are combined into ZFS RAID Z1 array, so I can lose one drive without losing any data. And the 3 of the 4 hard drives are formatted in XFS and combined into a MergeFS array. MergeFS is a user space file system that basically lets you combine multiple drives together and mount them into one folder. It also lets you mix file systems and drive sizes, and even use drives with data already on them. Now, having 2 separate storage arrays for fast and slow storage is a valid strategy, but my personal ideal storage setup for a NAS has always been to have both SSDs and hard drives appear as one file system in the OS. Then, if I write the data to the storage array via, let's say, Samba, the data will be written to the SSDs first, without waking up the hard drives or having to put up with the spinning rust write speeds. Then, I would have a weekly cron job that checks which files have the oldest last open date and moves them to the hard drive array. Now, I do have some exceptions, like for example my YouTube current folder, which I use to store the video footage for videos that I'm working on currently, is set to never be copied to the hard drives. But in general, this is the setup that I've had for years now, and so far, I haven't been able to find a good alternative. ZFS has its level 2 ARC, its ZIL, and its special devices, but it doesn't work quite like I want it to, and doesn't let you eliminate spinning up the drives entirely. Bcachefs, on the other hand, does feature a concept of tiered storage, but last time I checked, you couldn't tell it to schedule moving data from the SSDs to the hard drives. And seeing how it's also a subject of an ongoing drama in the Linux kernel mailing lists, I think I'm going to give it some time to mature. Now, the way I implemented tiered storage in MergeFS is by wrapping my ZFS pool with SSDs and the MergeFS pool with the hard drives into another MergeFS pool, first SSDs, then hard drives. This setup lets me keep my hard drives spun down for most of the time, and the only times when they do spin up is when accessing older data or data that I specifically chose to keep on the hard drives due to its size. Now, if you're using Unraid, this is pretty much how Unraid's cache pool works. But instead of Unraid's tools, I use a Python script to move the data from the SSDs to the hard drive array. And just like with everything else, I'm going to link this script down in the video description. Now, MergeFS is great and all, but unlike ZFS or even the Unraid solution, it doesn't really give you any redundancy. For that, I use SnapRAID. SnapRAID is a fairly lightweight utility that can calculate parity data from multiple drives and save it to a dedicated parity drive. It's similar to how Unraid does it, but unlike Unraid, where parity is calculated live, with SnapRAID, you'll have to schedule sync jobs in order to update your parity. Personally, mine are set to run nightly. The advantage is that your parity drive will only have to spin up during the parity sync or scrub jobs, and the write operations to your array are not bottlenecked by the speed of your parity drive. Speaking of scrubbing, unlike Unraid, SnapRate features checksumming, which can theoretically protect you from silent errors and bit rot. According to SnapRate's comparison page, Unraid doesn't have any kind of checksum, and just ignores silent errors. But personally, I think that one of the biggest selling points of SnapRate is that just like MergeFS, it allows you to use drives that already have data on them, as well as mix drive sizes and file systems. Another cool feature is being able to recover some data on your drives, even if you lost all your parity drives and some of your data drives. Basically, in something like ZFS or a traditional RAID, the data is written in stripes to the whole file system. And the reason why RAID 5, for instance, is not recommended for production use is that if you lose 2 drives at once, you lose the data on the whole array. SnapRate, on the other hand, has dedicated data drives and dedicated parity drives. So if you have one parity drive but then lose 2 drives at once, that will still suck, but you will still have access to the data on the remaining drives, since these are just independent drives with their own file systems, which are made to appear as one drive using MergeFS. If you want to be extra safe, SnapRate supports up to 6 parity drives, though I personally only have one. So here's my storage setup once again, and by the way, like many great things in this video, I stole a setup from Alex Kretschmar and his Perfect Media Server blog, so make sure to check it out. So that's all the questions for today. There were a lot more questions, but a lot of them are more like ideas for a full-fledged video and not really a question. So maybe I'll get to some of them in my next videos, we'll see. Anyways, that's gonna be it for this video. I hope you guys enjoyed it, and as usual, I would like to thank my patrons: James Uppington, Christoph Mueller, David Love, Scott Huffman, Yay Brianna, and everyone else supports this channel. Thank you guys for watching, and I'll see you in the next one. Goodbye.